right, this lesson is about the area of composite shapes. Composite. It's a figure that can be broken down into more than one basic shape. So if we look at this blue one here, we can see we have a rectangle, and two triangles. So that is composed of more than one basic shape. Here we have half a circle and a rectangle. Here we have lots of shapes. Well, basically rectangles and triangles. So we have triangle, 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 rectangle, rectangle. Okay, here we have two long rectangles, and I mean that possibly could be a square, but it's definitely a rectangle. This shape is made up of a rectangle, triangle, triangle. And then our hexagon here, that's made up of congruent triangles. Okay, so we're going to find the area of these based on the smaller, simpler shapes. So example 1 here, we kind of have a really long rectangle and we have another rectangle on top. Okay, so let's see. See, I might cut that off here. So I'm going to do this rectangle, which is going to be a 3 by 15, excuse me. But I need the length up here. I've got the side, it's 5, but I need the length. Well, if the whole horizontal length here is 15, then all of the horizontal lengths will also be 15. So if this horizontal is 4 and this horizontal is 6, that's 10. That means I need 5 more for the top. So that top piece is 5, the side is 5. Ooh, so we have a square on top. Okay, so the composite now. I'm going to find the area of the bottom rectangle. It's 15 by 3. So that area is going to be 15 times 3, which is 45. And again, we have centimeters squared because they did give us units. This piece is a square, so the area is going to be 5 squared. So that's going to be 25 centimeters squared. Okay, well now that I have each separate smaller piece, the rectangle and the square, then I can add them together. So my area is going to be equal to the 45 from the bottom rectangle and the 25 from the square. That gives me 70 centimeters squared. Okay, so I found each piece, and how you break it up is up to you. But I found each piece, and then I added the two separate areas together. So the area of example 1 is 70 centimeters squared. Okay, so for example 2, we have our half circle up here, and then we have a triangle down here. Okay, well our circle area, I don't like that. So the circle area is equal to pi r squared, and our triangle area is equal to 1/2 base times the height. So I need the radius. Well, 16 is going all the way across, so that means my radius is equal to 8. Okay, then for my triangle, I need the base. Okay, so I have that. That's the 16, but I need the height. I need to find this length. Well, since it forms a 90-degree angle, I have a right triangle, and they told me that the hypotenuse is 17. You could use Pythagorean theorem, but you should also recognize it as a Pythagorean triple. So the height is actually 15 because it's an 8, 15, 17 Pythagorean triple that we learned back in Unit 7. Okay, if not, do Pythagorean theorem, but that's the benefit of knowing the Pythagorean triples, so I don't have to. Okay, so I need to find the area of my circle. So that's going to be pi times 8 squared. That's going to give me 64 pi. Oh, but wait, I don't have the full circle. I have half a circle. So I need to take half of that. So that's going to give me 32 pi. And I'm going to leave it in terms of pi. Then I need to find the area of my triangle. So that's 1/2 base, which is 16, times the height, which we found is 15. Okay, well, half of 16 is 8. And 8 times 15, let's see, that gives me 40, carry my 420. So now I got to combine them. So I have 120 for the triangle, plus the 32 pi for the circle, and it's in feet, so it's going to be feet squared. Okay, so we're just going to leave it in terms of pi. 120 plus 32 pi feet squared. Okay, and we do need our units. Units are important. Okay, next we have example 3. So it looks like we have a rectangle, and it looks like they cut out the half circle and translated it. Remember, the word translate from unit 2 means we slide it over to the end of the rectangle. Okay, well, let's see. So it looks like I need, actually, I can simplify this quite a bit. So what happens if I take this piece and slide it back? It fills it in, right? That means I have a rectangle. My rectangle is 5 by 4. So the area of the rectangle is 5 by 4, which is 20. I do have my units. That's going to be inches squared. Otherwise, you would probably need to find the area of the rectangle, subtract the half circle, but then add it back on. So they kind of cancel each other out. Okay, so then I just have a rectangle, the 5 by 4, 20 inches squared. Okay, so for example 4, I have 2 circles, and I want to find the area of the shaded region. Okay, so I got to take that 4 centimeter circle out from the 10 centimeter circle. So I'm going to have one circle minus another circle. So I have the radii, because I have a radius of 10 and a radius of 4. So my area formula is pi r squared. So I'm going to take 10 pi times 10 squared, and then I'm going to subtract the pi times 4 squared. So that's going to give me 100 pi minus 16 pi. And 100 minus 16 gives me 84 pi, and then I have my units, centimeters squared. So again, I'm going to leave it in terms of pi, and I get 84 centimeters squared. So we are taking the basic shapes, and we are adding or subtracting, depending on if we have a shaded region or we're trying to find the composite figure. We're adding or subtracting the basic shapes that it's comprised of. Okay, so if I have 2 circles and I take part of that circle out, then I need to subtract it from the smaller circle from the bigger circle. In example 3 here, what happened was that even though I cut it out here, I translated it to the end of the rectangle. That means if I move it back, it fills it in and makes the rectangle again. Okay, if you want to look at it as a rectangle and a half circle, then I can certainly find that half circle area and take it away from the square, but then I have to add it back in. So they cancel each other out. Here, finding the composite figure, I'm finding the areas separate. I'm splitting it into a rectangle and a square, and then I add the 2 areas together. Here I have a half circle and a triangle, so I found the area of the half circle and the area of the triangle, and then I add them together to get the composite. Okay, now it's your turn to practice.